Getting ready for your first test of Chapter 6. On the test will be these 4 learning targets. I can write ratios in simplest form. I can find the unit rate and choose the better by. I can find the rate of change or slope, and I can solve proportions. Write ratios in simplest form. Here's a table. You need to look at the table to find these ratios. So I'm looking for the ratio of fish sticks to macaroni and cheese. So fish sticks, it looks like 4 votes. Macaroni and cheese looks like 14 votes. I'm going to write this in simplest form. Oops, but I didn't read my directions. Write the ratio as a fraction in simplest form. So I'm going to write the 4 on the top and the 14 on the bottom. Simplify those. I can divide by 2, and I get 2 over 7. So my answer is 2 over 7. Okay? Pizza to macaroni and cheese. Pizza is 64. I'm going to write this on the bottom. 64. And macaroni and cheese was 14. Remember, when we're writing ratios, we're not going to change this into a mixed number. But we can simplify. I can divide by 2, and I get 32 over 7. 32 to 7. All votes. Okay, so I'm going to add up all of these together. Let's see, I've got 6, 12, 13, 20, 100 all together. That works nicely. To macaroni and cheese, so I've got 100. And again, I've got 14. I could divide by 2, and I get 50 over 7. So 50 to 7. Pizza to all votes. Pizza has 64. All votes is 100. So I'm going to divide by 2. I could actually divide by 4 as well. Let's see, if I divided by 4, I get 16 on the top and 25 on the bottom. I can't simplify anymore. That's 16 to 25. And the last one, the last category is other, which is 3, and hamburger, which is 15. I can divide the top and bottom by 3, so I get 1 to 5. Write ratios in simplest form. Determine whether the ratios are equivalent. What I'm going to do is I'm going to write 2 ratios as fractions. So 4 out of 6 and then 8 out of 12. Okay? I'm going to decide if these are equivalent by multiplying the denominator to the numerator on both sides. So if I multiply this, I get 48. If I multiply this, I get 48. Are those the same? Yes, they are. So then I would say yes, they are equivalent. Same thing here. 20 out of 25 compared to 16 out of 30. I will multiply here, and I get 600. And I will multiply here. I'm going to grab my calculator for this one. 25 times 16. And I get 400. Are 400 and 600 the same? No. So, no, they are not equivalent. Find the unit rate and choose the better by. For these are just unit rate problems. It says round to the nearest hundredth, which is the same as the nearest penny in some cases, if necessary. So I'm going to take my one amount divided by the other amount. Typically, you're going to take your first amount divided by your second amount, unless it doesn't make sense to do that. So would it make sense to have dollars per day or days per dollar? I think dollars per day makes sense. So we're going to take our first value, $240, divide it by our second value, 4 days, and I get 60, which means $60 per day, and that makes sense. 50 miles in 10 hours, would miles per hour make sense? Absolutely. So I'm going to take 50, divided by 10, and I get 50 miles per hour. I'm going to write that MPH because that's the abbreviation for miles per hour. 32 people and 8 cars. How many people per car? Well, I'm going to take 32 divided by 8, and I get 4 people per car. 250 people and 5 buses. So again, I'm going to take 250 divided by 5. 25 divided by 5 is 5, so add a 0 to that, and that's 50 people per bus. Can't fit that, sorry. 18 cups for 24 pounds. Would it make sense to be cups per pound or pounds per cup? And in this case, either one kind of sounds the same, so let's just keep it in order and say 18 cups divided by 24 pounds, and I get 0.75 or 3/4 of a cup per pound. And $4.50 for 3 dozen. So I'm going to take my $4.50, divide it by 3. How much for a dozen? $1.50 per dozen. Okay? Which one's the better buy? In this case, I want to know what's the price for one, right? So I'm always going to start with money, and I'm going to choose how much is cheaper. So I'm going to take my $5.99 and divide it by 20. $5.99 divided by 20, and I get 0.2995. Well, in money, that rounds to 30 cents. So this first one is 30 cents. The second one, $1.29 divided by 6 cans, and I get 0.215. I'm going to round that to 22 cents. Which one's cheaper, the first deal or the second? Obviously the second one at 22 cents. So we're looking at the cheaper one, price for one. Here I can't buy 1 ounce of toothpaste, but I still want to know how much am I paying per ounce, because that's going to be the cheaper one. So I'm going to take my dollar amount divided by the amount of ounces. So I'm taking $3.29 divided by 30, and I get 0.10966666666 on and on. So I'm going to call that 11 cents. I'm going to write this one, with a dollar sign. So 11 cents looks like that, and that's more like what it looks like on your calculator. And now I'm going to take $1.79 divided by 18 cents. This time it says 0.09944444444. So I'm going to call that 10 cents, and I'm going to write that as money. Which one's cheaper, 10 cents or 11 cents? Again, it's the second deal at 10 cents. Find the rate of change or the slope. Here I'm going to find how much are things changing by and see what makes sense to put as my first amount and which one makes sense to put as my second amount. So first I've got the bottom of this changing by 1 each time. The top is changing by 8 each time. Does it make more sense to say how many markers per box or how many boxes per marker? And I'm going to say definitely markers per box for a couple of reasons. One, you put markers in a box. And second, there's more of them, so it makes sense. Otherwise, I'd have to have a decimal answer. So I'm going to say markers per box. And so there are 8 markers for 1 box, or we would just call that a slope of 8 or a rate of change of 8. Okay, here the top is changing by 1. The bottom is changing by 40. So what makes more sense, the cost per day or the days per cost? And I think for this one, the cost per day makes a lot more sense. We're going to take 40 for 1. $40 per day. That makes sense. I'm going to call it just a slope of 40. Here's another example of slope or rate of change, but this time I'm using a graph. Remember, you need to think whenever you're looking at a graph as rise over run. So we're going to write this as a fraction and simplify it when we're done. Okay, so I'm looking at how much do I go up by how much do I go over. So my rise is the amount I went up. I went up 5. It's 1 box, but if you notice it's counting by 5. $5. And when I go over 2 boxes, and they're just counting by 1, so that's going over by 2. I can simplify this as a decimal, but I'm going to leave it as a fraction 5 over 2. That can't be simplified. It's easier to leave it like that than to say 2.5 for if I was trying to figure this out later. All right, my second one, I go up 1 box. 1 box here looks like I'm counting by 2s, so it goes up 2. And we can see it's talking about money, $2. and then I'm going over 1, 2, and that goes over by 10. Every 2 boxes is 10. So I can simplify this, and I can call that 1/5, and that's going to be, or 1 to 5, it's going to be my slope. Solving proportions. Determine if the quantities in each pair of ratios are proportional. This is the exact same thing as asking if 2 ratios are equivalent. So I'm going to say 2 coins per 3 bills. Is that equal to 6 coins for 9 bills? So I multiply the diagonals and I get 18 on both. So yes, they are proportionate. 3 feet for every 1 inch, or 15 feet for every 6 inches. Here when I multiply I get 18. Here when I multiply I get 15. Those don't match, so no, they are not proportionate. Lastly, we're going to solve some proportions. Sometimes you're able to just see a relationship between 2 numbers. For example, here I see that 5 changes to 10 when I go over to the second ratio. So that doubled or multiplied times 2. I can multiply this one times 2, and I know that A equals 28. Whenever we can't find a relationship, we're going to go ahead and crisscross multiply, divide by the lonely guy. So we're looking for the 2 numbers that have values across from each other diagonally, and we'll multiply those, and then we'll divide by the thing that's left. So here I'm going to take 12 divided by 5, because 3 times 4 is 12, and I get 2.4. So x equals 2.4. Crisscross multiply, divide by the lonely guy. So I'm taking 72 times 2 divided by 4, and I get u equals 36. Oh, I noticed here that I have a relationship of doubling, so I could just take half, and that's how I would get this. Half of 32 is 36. I didn't notice that relationship first. Should look closer. All right, this one I don't notice a relationship, so I'm going to crisscross multiply 8 times 36. Divide by the lonely guy, so I'm going to divide by the 45 that's left, and I notice that D equals 6.4. Here I know that 10 and 15, there's a relationship there, but it's not an easy enough one to just see, so I'm going to crisscross multiply, divide by the lonely guy. So I took 120 divided by 15, and I get that M equals 8. And the last one, crisscross multiply 90 times 16, divide by the lonely guy, and I notice that T equals 40. There's no NICU check on this, but you do have a test, so make sure that you study. You can do the online study or lesson quizzes. That would be a really helpful way to practice. This was on lessons 6-1, 6-2, 6-3, and 6-6. So those are the 3 lesson quizzes you would like to try. Have a good night.